contributed significantly to academia, having previously worked at various esteemed institutions, including the College of IT and Management Education, Bhubaneswar, and Madan Pale Institute of Technology and Science, Andhra Pradesh. His research interest lies in HRM, organizational behavior, corporate social responsibility (CSR), and tourism. He has published extensively in national and international journals and has authored 20 plus books in the field of human resource management and business communication. Additionally, he has served as resource person for various faculty development programs and industry-oriented training sessions. Dr. Sahu is an active member of professional organizations including the National Society for Development and Sustainability in Japan and the National Human Resource Development Network in India. He has also played a key role in organizing international conferences and workshops. Beyond academia, Dr. Sao actively shares knowledge through his blog and YouTube channel entitled MBA Today by Dr. Chandrakanta Sahoo, aiming to guide the students and professionals in the field of management. I would like to invite Dr. Sahu sir to take over the session. Over to you, sir.
Thank you, ma'am. Good morning, participants.
Good morning, sir.
Am I audible to all?
Yes, sir, you are audible.
Yes. I am sharing the screen. Share the- Is my screen visible?
Yes, sir, it is visible.
Okay. Thank you. Good morning to all the participants and welcome to this day 4 session of the FDP. As you know, this FDP that titled Research Methodology and Grant Writing. It has two components. One is research methodology and another is grant writing. As far as research methodology is concerned, we need research because society has enormous problems and we as academia, we as responsible academicians, we have to address those problems. Okay. To begin with, we need to find out what are the problems. There are many ways we have to identify the research problems. Sometimes we make research like literature review, sometimes we go for field survey, small sample survey or pilot survey, sometimes we also go for like a FGD kind of survey in qualitative research, focus group discussions. Okay. So the basis of doing research is data. And how do we collect data? We need a method. Okay. And when we discuss about research methods, it has certain components. It has a, it is it follows standardized step-by-step process. So we have business problem or we have some research problem. Okay. If we are in the domain of business and we are teaching business subjects, then we can look for this business problem from different business houses. Okay. So we have problems. We have to find out a solution to the problems. Okay. For that, we have to collect data. How do we collect data? Okay. As you know, that there are different sources of collecting data. Okay. So primary and secondary. Therefore, what we need to do, we have to use some of the research instrument to collect data. It can be the primary instruments can be questionnaire, one FGD, it can be focus discussions or pilot survey. Okay, and from that, or sometimes we may also go for the secondary data. Okay, and from these small samples, or sometimes from secondary source, when we get some insights into the research problem. Okay, and we also refer to previous like, review kind of papers. Okay. So we get assumptions. Okay, we get hypotheses. We derive hypotheses from those kind of works. Okay, and this sometimes this happens. We conduct some of the research, or we review some of the papers in the context of USA or Japan, but those contexts may not be applicable. But for that, what we need to do in the Indian context, we have to do. Sorry, sometimes this can be applicable. The factors that are that affecting in USA may also affect in Indian conditions. But in many of the times, what happens? These do not that these factors may not be applicable in that Indian conditions. You may get some that new factors. Okay, Indian suppose like for example, I will say if you go to that Pizza Hut, okay, Pizza Hut, you see people didn't appreciate pizza when that it came to India, because we have a different taste. We had a different taste, but over the period of time when there was cultural indoctrinations, people of India appreciated pizza. It took years to appreciate pizza. Okay. So sometimes the research that are being conducted in some foreign context may not be applicable in Indian context, and in Indian context there may be different factors that are influencing a certain particular kind of behaviors. Okay. So the best is that when we have the research methods, we collect certain kind of data, we follow certain sampling frames like sampling techniques or sampling size. We also that as per the requirement we do all these things. Then next part is your data collection. As next part is your data that analysis. The subject that we are going to deal with today, hypothesis testing, that means we have already collected the data. Okay. We have already collected the data, and we have certain assumptions, and the assumptions or the hypothesis, these are called hypotheses. These hypotheses we need to test using certain kind of that analytical tools. So we have today, if you see, like two sessions that we are going to have here today. One is parametric test, and another is non-parametric test. Okay. So there, this in the morning sessions that I am going to deal with these four kind of tests very quickly. We will wrap up all these things, and in the afternoon sessions I am going to deal with these four kind of tests. Okay. So these four kind of tests, these parametric four types of tests, and these non-parametric four types of tests. When we are going to use a particular kind of test, and we must understand the nature of the data. As researchers, when we have a research frame, we develop a research frame, what happens? In our mind, it should be that suppose I want to use independent test, what kind of questionnaires or what kind of data that we need to run one independent test. We must understand. And similar is the case of that like paired t-test and also all this. So when we have a test in the mind, and accordingly we design a questionnaire and we collect data so that a particular kind of test can be used for analysis purpose. Okay, for analysis purpose we need. So these two kind of tests, if you see, these two kind of tests, if you see, one is parametric, another is non-parametric. what kind of what assumption that we must have, what kind of data that we must collect, okay, and what are the prerequisites to run this test. In case of, broadly speaking, if you see parametric and non-parametric, okay, broadly, then we will go to the particular, because there is a theoretical aspects. Unless you understand the theoretical aspect, you cannot also apply it. So let us understand. So when we have a data sets, so basically, if you see, two assumptions keep in mind. Whether your data is a normal data, your normal data will, when you spread your data, it should be like this. Okay, it should be like, suppose you are collecting questionnaires, there are some questions or items, and you have a rating scales like 1 to 5 or 1 to 7. Okay, that means you must have, like when you make a distribution curve, your data has to be like this. That means, what does it means? The data needs follow a distribution curve. Or what happens, sometimes your data may appear like this. These are called skewed data. Hopefully you understand. Okay, that means, suppose this is 1 2 3 4 5, this is 1, this is 3, middle part is 3, this is 5. That means most of the data, if you see, are concentrated at the left side. Means there are like 1 2 people have given the responses, so you cannot have a distribution curve. Similarly, if you see your data distribution, like at the right sides, you can see. Okay, you see, so right side data, this is not a normal data. When you do the distribution curve, these are not normal data. So when you do this, you can check this with the help of histogram also. Okay, you can check this with the help of this histogram. When you superimpose a curve on the histogram, you will find whether your data is a normal data or it is a skewed data. Skewed, left side the data is skewed, or right side your data is skewed. Okay. There is another aspect also I would like to tell you. This is when you do this normality, there is a KS test. I will also show today that how to that conduct one KS today. Okay, so I will show you. This is Kolmogorov Smirnov test. So normality you can do with the help of histogram. There is also another like PP plot or QQ plot. You can check. There are multiple of ways that you can check whether your data is normal or not. So you can check this graphical display. This, then you can check also kurtosis and skewness. This is also another way of doing. And normal distribution, the skewness and kurtosis has to be 0 or +1 or -1 in between. Then you can also call it a normal data. Okay, then you can also find there is a case test, like the data, if the data is like significant, you will see a significant p value is significant, means less than 0.05, significant, it is not desirable, non-desirable. The data has to be insignificant, that means p value has to be greater than 0.05, then you can call that your data is normal. Okay, so these are this, in this way, three ways, there are three ways that you can assess normality of the data. If if you are finding that that data is normal, then you can go for parametric test. Okay, else you can go for non-parametric test. Okay, let me show you that another prerequisite of running this parametric test is homogeneity of variance. What is homogeneity of variance? You can see I have taken two examples. There are concerts, there is a like a group, okay, and they're organizing different concert in different locations. Okay, you can see the spread, the sound spread, it tells about sound spread. Sound is very much concentrated. Okay, it is not that spread. Okay, disperse, this is not that disperse. You see this, that what is the range of sounds it is talking about here. But here you can see data is heterogeneous, means you can see it. Okay, data is highly spread. Some people are getting, some people are able to hear, and some are not also able to hear. So you see the data, the difference. So this is called homogeneity of variance. These two kinds of tests that you must run before selecting a parametric or non-parametric test. Is it clear? Number one, what we did, that we have to assess the normality of the data. Normality of the data means we have to go for case test or visual kind of display or QQ plot or PP plot we have to check. Then we have to check the homogeneity of variance. There is another kind of test that is called Levin test. Okay. These are the minimum two requisites that you have to run. You have to check before selecting a that parametric or non-parametric test. Is it understood? Is there any question? Is there any question? Yes, go ahead. Okay, okay, thank you. I'll check now that I have that shared one like one data set. Okay, that is national seminar. Those who have already this spaces, you can open their data sets. Have you got it, everybody? Have you opened the data sets? Everybody, please write yes if you have. Yes, great. Please open the data set national seminar if you have it. I have in the morning, I have posted this. There are some data sets I have posted in the group, WhatsApp group. Okay, so you can open if you have SPSS. Yesterday, I also shared the trial version of SPSS. Okay, hopefully you have done. If you have done, you can do it. So that we can do it simultaneously. We can practice. Okay, so you can see this is national seminar. Is my screen visible to all?
Yes, sir.
Yes, sir.
Okay, thank you. You can see. So this is the interface of spaces. We'll see the this that variable view. This is the variable view. Okay, one strange variable we have taken. This is the text based. This is this is gender. What we have done, we have coded it. Like we have coded 0 for male and 1 for female. We have coded it. Okay, this is nominal data. Okay, nominal data, and these are the 3 day data. Okay. So just a minute. One university has organized 3 days national seminar on digital India. The coordinator of the program was worried about the potential health effect of national seminar and measured the hygienic conditions of the place and collected data from 800 participants over the 3 days. That means this national seminar has been conducted for 3 days and there were 800 participants. Okay, at the day one. Then in the day two, as you know that this happens, day one some candidates will be there, day two they will not be there. There are some missing data like that, and there is some missing data in day three and day four. Hygiene was measured using a standardized technique that collect in a score ranging from 0. That means they have been asked that if the you have found the place is not hygienic, that means you can give 0 or you can give maximum 4. Okay, if the respondents they have found that the place is really hygienic. Okay, so now, okay, uh, now I know from bitter experience that sanitation is not always great in this place. Okay, when there is huge gathering, normally this condition sometimes it may get deteriorated. So this researcher predicted that personal hygiene would go down dramatically over the 3 days in the national seminars. Okay, this is inspired by Andy Field. Okay, let's see. You can check the data now. Okay, you see we have code 800 participants are there. You see day one all the participants were available, and day two some of the participants were found to be missing, and so also in day three we have found. Okay, you can see we have coded this. You can see male, there are male candidates are there. Okay, there are female candidates are also there, male female. Okay, for male we have coded at 0 and female we have coded at like 1. Okay, you can see this is reflecting here. Okay, 0 for male, female. Okay, so how do I check? How do I check whether my data is normal or non-normal? Okay, you can see analyze. You can please practice with me. We'll practice very slowly. If you have opened this data set in SPSS, okay, analyze. You have analyze. Then you have descriptive statistics. Okay, if it is done, tell me yes. Is it done? Can I get your response if it is done? Hello.
Yes, sir.
Okay. So analyze descriptive statistics, then go for explore. Please have a notepad by the side so that you can write the path. Is it done? Explore. Okay. Then click. Okay. So now you can see we have seen we have 4 variables here: gender, day 1, day 2, day 3. Okay. Day 1 we have got all 800 samples, and day 2 there are some missing data, and day 3 some missing data. So gender of participations will take to factor list. You can see, you can select here and click here in the arrow factor list, because this is string variable. This is a string variable. Got it? Then you can take this hygiene conditions of day 1 and day 2. Day 1, 2, 3. These are the hygiene condition of day 1, 2, and 3. You can import these to dependent list. Please everybody practice with me. If it is done, say me yes. Is it done? Or say me yes. Else I have to see here. Okay. Then click on statistics. Okay. You can see descriptive we have taken here 95%. Interval of means 5% significant we are taking here. Okay. Then we don't need to, because if we want to check the outlier, we can check, else we can write continue. Okay. Then let us see what it is. So we need what we need. We need histogram. Histogram means we need to see the normality of the curve. Okay. Therefore, we need to check histogram for all these days, 3 days. Okay. You can write here, this is normality plot with test, because it will give you the significant value. Okay. Like what is the that p value it will give us. Okay. So this is a case test that when we click here, we will get the case test value. Okay. Then spread versus 11 with 11 test. This 11 test is called the test of homogeneity of variance, that I check that concept pictures that I set. So that test will see whether it is that data is that homogeneous or not. You can click here on transformed. Is it done for everybody? If yes, please tell me yes.
Yes, sir.
That's great. Okay. Then continue. Okay. Then we'll check the options. Achha. This is important. You see. What it is, first one is exclude cases list wise. Okay. Second one is exclude cases pair wise. Click on second, because we are having some missing data. You can see day 2, day 3, some missing data is this. So pair, when we are checking these in pairs, the missing data is there, therefore we see it. Okay. So what happens when we don't select this pairwise? Okay. That means that will not get noticed how many people are left in day 2 and day 3. Okay. So therefore, since it is in pair, we have to check the pairwise. Then continue. Then nothing to do. You can here display both statistics and plot. Both we have selected. Okay. Then okay. So now we'll get the result. You can see this is a case processing summary. You can see the day 1 it is 800, 305 male and female 495, 100% data. Okay. There is no missing cases here. You can see here it is 100%. Okay. So day 2 you can see day 2 male 102. You see how many people are reduced. You see 33%. It has become 33%. 100% becomes 33% here. Okay. So 203 people are missing here. You can see 102 attended. Then female you can see similarly this 495 becomes 160 and 335 people were missing, and these are in what that percentage these have been taken. Okay, the total. Yeah, I think it is easy to understand. There is no problems in understanding day 1, day 2, day 3. Okay, descriptive statistics we can see. Okay, you can see. We'll see how many days. How many days? Okay, so this is 3 days. For 3 days, we'll check the data whether data is normal or not normal, or it is data is homogeneous or not homogeneous. You can see the day 1 data, it is mean is found to be 1.59. Okay, it is found to be. This is 95% of confidence level, lower bound and that upper bound it has taken. What does it mean? Sometimes what happens, data is having outliers. Okay, data is having outliers. What does it mean outliers? Suppose take for example, we have a sample frame where we are finding most of the people are having the income between 10,000 to 20,000 or 25,000. Okay, what happens? We find some of the respondents who are having like one respondent is having 500 rupees. Okay, and 2-3 respondents are having like per month income is 5 lakhs. Okay, these are called extreme data outliers. Therefore, when we take this 95% interval upper mean, upper bound, this 5% we delete here. Okay, then we get the tree mean here. Upper bound is this and lower bound is this. So as a result, we are getting 5% tree mean. Tree means 5% that outlier we deleted. Therefore, 5% this trimmed mean becomes 1.58. You can see the actual mean is 1.59. Therefore, this is the difference. Actually, we have deleted 5%. Okay. Then variance, we have got the variance here. You can check. Okay, we have got the variance. Okay, how individual observations are varying from means standard deviations. We have got it. Okay. Then minimum value and maximum value. That means day one someone has given 0.11 and maximum someone has given as 3.58. This is the range. Okay, range means this maximum minus minimum. This is called range. Okay. Then skewness, you can see this is important that we are going to check. Okay, this skewness is 0.213 and minus 0.66. What does it mean? Actually, this skewness, ideal skewness value has to be 0, but if it is in between -1 and +1, that means data you can conclude as normal. Achha. Then you can come to the female. Same thing, the similar way you can see, you see. How the maximum value can be this 20? It cannot be. You can see this one, maximum value is 20. Is it possible? We'll get a response 20 having the 20 as response. What is the scale that we are using here? Anybody? Anybody? You can see. This is that for poor 0 and maximum excellent arrangement. The respondent has to be given the response as 4, not beyond that. But somebody has given 20. How is it possible? Is it possible? Hello?
No, sir.
It is not possible. That means it is a topological error, type errors. This data needs to. It's a.
Susan Mahapatra, sir, please mute yourself. Susan, Susan Mahanti, sir, mute yourself.
Yes, thank you.
Welcome, sir.
So you can see there is an error. This is a topological error, type error. The respondent could not have given this response actually. When you type it,
Sushant Mahanti, sir, please mute.
madam mute kar diyantu. Please mute him.
Okay, sir. Sir, continue, sir.
Some background that sound is coming still. Okay, so okay, this is maximum. That means what does it mean? This is a topological error. Please note it so that we can rectify this. Where is the error? And this is the error in day one. Okay, day one you can see female data. We have the error. Okay, please note it everybody so that we can correct. Okay, so let us move to second day. Second day, similar way you can have also, you can see. So mean has reduced, you see. It is point less than 1 every. Okay. Similarly, if you see skewness it is a little more, you see. More than 1. And that means this second day, male data, if you see, this is not the normal data because it has to be within +1 and -1. This is not normal data, you can see. Okay. It has been found. We'll see. Once again, we'll check also after correcting the data if we are getting that normal data. We'll see. Okay. So female, if you see this data, okay, this is also normal data. You can see skewness and kurtosis. This is also normal data. Okay. Then day 3 male data, you can see skewness and kurtosis. This is also normal. You can see. Okay, this is also normal, and female data also, it is also normal, you can see. Okay, hopefully you have understand. So you have understood. Now we'll see the day 1 will correct this data. Okay. Where is this maximum value 20? Where is this? So in order to find out the error, where actually the topological error has been caused, that committed, you have to go and check it is day 1 data. Since it is day 1 data, you can see this is here the hygienic condition of day 1. Okay, so here there is a box plot. You can click here, you can see. You see that respondent number 672, okay, has given the 20, has been given the response as 20. Okay, this needs to be, so actually this range, if you see 0 to 4, it has to be, now it is now 20. So therefore we have some problems, like this has appear as outlier because maximum you have to give 4. Now that the response has come as 20, so it has appeared as outlier. Now we'll correct the data. Okay, we'll correct the data. So what is the case number? It is 672. We can go to edit, go to case, data corrections. Okay, go to case. So what is the case number? It is 672, I think. 672. Then go 672. You see here the data. It is really, it is by mistake. It has been typed as 20, whereas it has to be 2. Okay, the data has to be okay. So now it has become 2. We have rectified. Once we have rectified, what we'll do, we'll process this once again. We'll check whether what is the change that we are finding. Okay. We'll analyze descriptives, then explore. Okay, all these are there. Already we have selected. Once again, we'll is okay. So let us see the day 1 data. Female data, day 1 female data, you see. So maximum it has, because you see it is there is a change. Okay, there is change. So 0.2 and this is maximum, it has become 3.69. Okay, 3.9. Okay, now the data has become normal, you can see. Okay, data has become now normal, means minus +1 and -1 in between data. So the data has become normal. Okay, got it? So now we have checked the kurtosis and skewness as far as normality is concerned. Then we will see another case test. We will see test of normality. You can see here for day 1. You can check.
Sir, one question, please, sir.
Yes, please.
Sir, because the range is from 0 to 4, right, sir? Somewhere we find that number is given beyond that value, as here it is 20.
Yes.
So how we consider that data 20 to 2, not 4? Because when it is a highest value beyond that, why not we go for 4? Because how I assume that he want to retain 2, but it is by mistake 20. Because 2 and 20 is 0. They are having a different place in the keyboard.
Yes. Sir,
and
you are right.
Why not we ignore that data?
And that can we also ignore? No problem, because you have a sample size of 800. You have a sample size of 800. It is not 4.5. You can ignore that. It can be also that 799. That's fine, no issue, sir.
So we can ignore, because if there is some data, you can go for yes, sir. Yes, sir.
No, you can ignore, sir. you can ignore, no issue, sir. Because 800 sample you are taking, your sample size is very huge. You can ignore, no issue, sir. But it is assumed that by mistakes the typewriter has typed it. That is my assumption. You may also disagree. Okay, so it could be 2 instead of 20, because beyond 4 you cannot type.
Sir, suppose there are more than 50% data is having this abnormality. Then
No,
if you assume all this value,
no, it cannot be, sir. It
sir,
cannot.
suppose there are 30 to 40% data having
Eh,
this type of thing.
No, sir.
So
Sir,
if we put assumption on this, then the estimation may be wrong.
100% wrong. It will be.
Sir,
Because you have certain limits now. You are that using a scale, sir. It is 1 to 5 or 1 to 7 or 0, whatever. You have developed a scale. So your
right,
data, your
right.
responses cannot go beyond your range. Suppose, sir, we are teachers. We are that conducting examinations for 100 marks. How can we give 200 or 150?
Right, right, sir.
It cannot be, sir. That means
Sir,
the problem doesn't. Problem is not with the students. It is with us. If we are giving.
right, right.
Okay. Therefore,
Okay,
just
thank you, sir.
if we want to collect that correct, we can correct, or you can ignore. Sample size at 799. It will not make much difference because you have a huge samples. Okay. Okay. Hopefully, I have addressed the concerns. Okay. So you can see.
Sir, sir.
Uh-huh. So now you can see this is just we are checking that normality and homogeneity of the data, because these are very important before selecting whether you want to that use a parametric test or non-parametric test. You must have these two assumptions minimum you have to do. Your data must be normal, your data must be homogeneous if you want to run parametric test. Okay, for this you have to check all these things, that like that kurtosis and skewness. If it is fine, okay, you don't need to go for other also. That's all fine, there is no problem. But there are multiple of ways that you can see. So let us go for test of normality. You see, day 1, day 2, day 3. Okay, you see, test of normality is a Kolmogorov-Smirnov test. Okay, and see, so the p value you see, day 1 p value is okay. You can see. That means in order to select a parametric test, your data has to be normal. Normal means here you have to check the p value, significant value. Okay, significant value must be greater than 0.05, means non-significant. It has to be non-significant. Then you can call your data is normal. Your day 1 male data is non-significant. This is normal data. But here female you are not getting this. Okay. Similar day 3 also male you are getting 0.06. Okay. This is also, if you see, this is also non-normal. This is desirable for what you call that for parametric test, but this is not desirable. Are you getting? So this is, you can see test of homogeneity. If you see, to a test of homogeneity based on mean, if you see, this is 0.0, it has to be greater than 0.05. This is also not desirable. This is also not desirable for parametric test. This is also not desirable. So what we can conclude from here? We can conclude that the data set that we are using here, this data set is not suitable for running a parametric test. It may be this is, you see, 3 days na 3 days means you cannot run one ANOVA for this. Rather you can run one Kruskal Wallis, it will work. Okay, so in a later part actually I will discuss this. Okay, so basically let me summarize what we have discussed. When we select a parametric or non-parametric test, it is significant that we must run certain kind of test that the data is suitable for using a parametric test or parametric that non-parametric test. Okay. So for this, you can check this skewness and kurtosis, or you can you can make one histogram to check the normality. And also what we can do, we can also check that KS test. You can also run a KS test, or we can check also, you can run also Levin test to get this. Okay, hopefully we have done it. Similarly, you can also check like where is the, just a minute. Histogram we have not taken. That means it is not appearing, means we have not taken. Histogram we have not, so perhaps we have not selected. Otherwise it could have come. Oxford is okay. Okay. So oh, okay. Now we'll see this parametric and non. So now we have checked the normal, we have run the normality test, and we have run the Levin test, that is called homogeneous test. Now we'll that see the questionnaire design for running this kind of test. Okay. Basically, if you see, there are a minute. Okay. We have here 4 kind of test. One is 2 sample test. You can see this is 2 sample test. If 2 sample means, what does it mean? Suppose there are boys and girls. Okay, there are boys and girls, students in the class. Okay, there are marks. Okay, there are marks. They have been given marks in a particular subject. We want to test whether there is a significant score, a significant difference in mark of a particular subject of boys and girls or not. That means when we develop H0 or null hypothesis, that's why it's a null, means there is no significant difference, means almost they are equal. There may be difference, but the difference in mean is not that significant. Are you getting? This is called null hypothesis. Okay. As far as H1 is concerned, that's when there is a significant difference. Let us understand this clearly. That's null means there is no difference, significant difference. There could be difference, but this difference is not that significant. What does it mean? Suppose that, for example, some of my students who join in a particular company, suppose 20-30 students have joined in a company, and somebody is getting like 5.5, somebody is getting 5.52, the difference is 2000. Okay, whether this difference of 2000 is significant or not, or somebody is getting 5.5 and another person is getting 3 lakhs rupees, the difference is huge. Whether 2 lakhs, this 2 lakhs or 2.5 lakhs difference is significant or not, this we are going to check here. Okay, so when we keep this independent t-test, your samples must be independent. Okay, they should not be exclusive, they should not be inclusive, they should be exclusive. Distinctive means boys are different, girls are different. Okay, but if you see the paired sample t-test, the paired sample t-test means, suppose take for example that a doctor, okay, a doctor is having some of the patients, okay, and these patients are suffering from obesity diseases. That means they are suffering from overweights, and doctor want to give them some diet plan, take for example, and some advice doctor get. And the people who are suffering from, the patient who are suffering from certain kind of diseases like obesity, they have to follow strictly. Okay, so what happens, the same patient is tested twicely. Today is the baseline. Like a person, his weight is 90, take for example, and he has been given a treatment. Advice that you run, you go for walk 5 kilometers in a day. This is your diet plan, and you follow strictly whatever the doctors advises. Okay, and these patients are following. And after 1 month, what happens? These doctors, these patients were once again tested. Okay, so now it is 95 today, and after 1 month it is, or after 1 month it is becoming 90, or it is increasing 101, take for example. Okay, so that means here what we are doing, the same person or the patient is observed twicely. Are you getting? Am I audible to all?
Yes, sir.
Okay, thank you. So here what happens, same person, respondents, is observed twicely. The respondent remains the same, but he has been observed twicely by the doctors. So therefore, these sample are paired here. That means before and after. Similarly, suppose take for example, we can have another example like a faculty development program. Okay, attitude towards academia. There is a faculty development program. Okay, so what is the attitude of the faculty members towards academia before the training program, and after the training program? What attitude? It is a perceptual survey. Okay, it's a perceptual survey we are doing. Okay, so before the training program, what was what was the attitude, and after the that training program, what is the attitudes? Okay, we are measuring. So before and after situations we are comparing. Okay, similar kind of examples that we can cite. Suppose take for example the uh, in a project that displaces people, like that Kalinganagar, take for example. So before, there are many people who are displaced by Tata Steel in Kalinganagar. So before Tata Steel came up there, what are the social economic conditions there? Okay, one some questions that you are that administering and collecting the responses, and it can be also longitudinal survey. So after 10 months or 10 years of that project implementation, what are the socio-economic of the, what is the socio-economic conditions of the people? That before and after you can do it. Okay, so similar kind of, if you have a questionnaires that collects data, okay, before the interventions and after the interventions, that you can use this subject to condition that your data must be normal and what that homogeneous. Okay, is it understood?
Yes, sir.
Oh, good. So more than two samples, what are more than two samples? More than two samples means, suppose take for example that spending habits of people belonging to lower income group, middle income group, higher income group. Okay, or three samples. It has become three samples. Three sample group you see: lower LIG, HIG, okay, and MIG. Three groups. So you can have this ANOVA. Okay, are you getting? Similarly, suppose take for example you are doing certain kind of community survey or caste-based survey. So SC, ST, OBC, and general, four kind of samples that you are using, sample groups. Okay, so for this you can have this ANOVA. You can use ANOVA. Okay, so here the similar things. Suppose the persons are suffering from obesity disease, and now what happens? You are administering that, it is baseline survey you did today, then they have been given certain advice or treatment that you go for a walk, 5 kilometer walks, and come back and have some hot water and lemon or honey, and similarly you practice for 4 5 months, doctor advises, and the patient went strictly followed, and this is today the baseline. After 1 month they have been once again measured, their weight after 2 months, what is the weight after 3 months, what is the weight 4 months, what is the weight, likewise, and so on. So you must understand that there is always, when you use a test, there is theory behind this, because what kind of data that you need to that have, or you need to collect to you to apply a particular test. Okay, so it is here two sample test, it is more than two sample tests, just as I talked about 1 month, 2 month, 3 month, 4 month, or baseline kind of things. Okay, so the difference is that when your data is not normal, okay, your data is not normal, you can go for a, this is the substitute for this, you can go for Mann-Whitney test. Okay, your data is not normal, so both assumptions has to be fulfilled. Means data is normal but not homogeneous, no, you cannot run parametric test. Okay, so this Mann-Whitney test is the substitute to independent t-test. Why it is called independent test? Because those scores are independent. These are not inclusive. The way we treat about this, the observer, the same respondent is measured twice, but here it is not happening. Boys and girls, their mark. You can see there is a strange variable here. But here, if you see, the same person has been measured twice, before and after. So if your data is not normal or homogeneous, you can go for Wilcoxon test. These are called. Okay. So similarly, this is two sample, this is more than two sample, three, it can be 3, 4, like kind of things. If your data, if it is not homogeneous, okay, or normal, you can go for this Kruskal-Wallis. Okay, this is the substitute and this is the substitute for this. Is it understood?
Yes, sir.
Anybody? Because we will run another we'll use another data set here. We'll say start with independent t-test. 1 hour is over. Okay. Let me assume that you have understood. Okay. Let me close it. There is another data set that is called salary. You can say open. So this is the case study that we are going to discuss. Okay, this is just one that simulated data. This is not the real data. Okay, the example to know whether the salary of male faculty members in private institution is equal to salary of female faculty members. Researcher collected data from 20 male and 20 female faculty members in private institution to know the difference. Okay, whether there is a salary discrimination, whether there is equal pay for equal work practice in private institutions or not. Okay, so what the researcher did, the researcher collected the data of 20 male faculty and 20 female faculty. Okay, so this is the data set, salary data set. You can see. Okay, and see variable view. We'll see. So there is a gender here. You can see we have coded this gender as male and female. This is the label. Hopefully you can code Everybody can code all these things. Okay. So this is the label. What is your gender? That is being asked. Okay. What is your gender? Then what is your salary? Okay. So this is the string variable. This is coded. Therefore, it is nominal. Okay. So this is a scale variable we have taken. Achha, you can see the code is reflecting. This is male, female. Okay. I have coded this, and this is the, you can see male 45, another male faculty 46, 54, female faculty 38, 29, like this. These are the values that are being given. These are the data collected from the faculty members. Okay, male faculty and female faculty. What is the sample size? 20, 20. Okay, male faculty 20 and female faculty 20. So you tell me what we should do first. What should we do? What we need to test first? We need to test. We need to test. We need to test normality and homogeneity. Okay. So you see here, this is the strings variable. What is your gender? You can bring to factor list. This is numeric variable. Okay, this is a number. Salary is a number. You can take it here. This is a factor. Okay, gender is a factor. Okay, we have just coded as 0, 1, and 2. Okay, so we can see here statistics. We can check this descriptive statistics. This is confidence interval for being 95%. We are taking, means significance level is 5%. Okay, so estimators, outliers, percentile we are not going to check. Continue. Then we will check the normality. Okay, histogram we can check for, this is also normality, this is also normality. On transform, you see here it is written spread versus label with level test. Okay, so on transform, this is for what? This is for homogeneity test. Okay, then continue options. So there is no missing data. You can see, therefore we will continue with this. Okay, this is nothing, this is not required. Then it is both. So you can see, so 2020 there is no missing data, you can see. Okay, this is salary. You can see we have discussed in the previous sessions. So what is the salary of teachers? Male, this is for male, 49,000 average. Female is 39,000. There is a difference of almost more than 10,000. Okay, whether this difference is natural actually. Okay, but whether this 10,000 difference is significant, we will run a t-test for this. Again, this is 95% confidence interval level for mean. You can see 5% trimmed mean. Okay, then variance, this is standard deviation, tells about dispersions. Okay, maximum salary among, minimum salary among the male faculty is 34,000 and maximum salary is 64,000. Range, this is the range. Okay, difference it is talking about. Skewness, you can see the data is appropriate. This is normal data. Okay, because skewness and kurtosis value is in between +1 and -1. Similarly, you can see also male faculty, female faculty 39,400. Okay, then you have this minimum is 28 and maximum is 54. Range is 26. This difference. Okay, 26,000. Okay, skewness is this +1 -1 in between. The data is normal. Okay, so descriptive statistics it tells about. Then you have also this like test of normality. You can see test of normality. You can see this is 0.2 case test. Okay, Kolmogorov Smirnov test 0.2, and this is also female also 0.2. What does it mean? Significant value is 0.2. It is significant or non-significant? Anybody? Are you waiting? Tell me. This is significant value case test. 0.2 is significant or non-significant? Significant means the value has to be less than 0.05. That means here value is 0.2. Is significant or non-significant?
Non-significant.
Non-significant. Very good. No,
Non-significant.
uh, non-significant. This is what is desirable in case of parametric test. Please remember, this value of normality test has to be non-significant. Means it has to be greater than 0.05. The value is greater than 0.05. What is desirable to run the t-test or a parametric test? Okay. Sample size is this. So this is a mean test. You can see based on mean. This is 0.4 test of homogeneity, 11 statistics you can see. What is this? Are you getting? 0.435 is significant or non-significant?
So non-significant.
Non-significant. This is what is desirable for a parametric test. Very good. Achha. This is also one way we can check also. You can see. Okay. Elements. I am just superimposing the curve. You can see. This curve is looking like one normal distribution curve. Okay. Is it understood? This is a normal
Yes,
distribution
sir.
curve. Okay. Similarly, this is for male. Female, you can see. This is female. Click here, double click. Then we will get here elements. Then show distribution curve. Okay. Then close it. Okay. It is also normal. You see, this is normal. It is not skewed. Got it? So this is also, this tells about normality. QQ plot. Let us see. You see, you can see QQ plot or PP plot. When you see, it has to be, you see, diagonal view. It should not spread like here there should be one value, here there should be value. Like this, it should not spread. It has to be in the way it has been here. Okay. That means this is also normal. This is a null actually. This is not required. This is also null, not required. QQ is required to be like this. Okay. Okay, very good. We'll run the test. So now how many samples are there? It is two samples. If you see, two group samples. So now we'll process this. Like this is analyze. Please note down the process. Compare means this is independent sample t-test. Okay, independent sample t-test. Okay. So gender, you can see define group 1 and 2. I think we have coded. We have coded as 1 and 2. Two groups are there. Okay, 1 and 2. Then this is the salary of teachers. You can import here. Is it done by everybody? Is it done by everybody?
Yes, sir.
Great. Then options, you can see it's fine, nothing to do. Continue. Okay, you can see. So group statistics. So male sample size is 20, female also 20. Mean is 39,900. Here 39,400. Standard deviation is this. Okay, this is the square of variance. Okay, this is the standard error of means. What is means? The error value, the lesser the error value, it is good. Okay, error has to be minimum. Acha, this is the independent t-test. You can see independent t-test. You can see equal variance assumed. Equal variance assumed. Okay, this has to be. You see, what is the equal variance assumed? This is required to be. You can see f value is this. Okay, so you can see it here. This is. This has to be. You see. Interpret this. So what we have found here, equal variance assumed, required to be, this is required to be so here we are getting the t value is 4.088. So this is the degree of freedom. How degree of freedom is calculated here? Okay, so degree of freedom is calculated because you have two samples. Your 40 minus 2 is 38. Okay, so it is found to be significant. Okay, so therefore it is as that it can be concluded that the salary, there is a significant difference in salary of male faculty and female faculty. Means the private institutions doesn't respect the principles of equal work, equal pay for equal work. Okay, this is it. So on an average, if you see male faculty member getting more salary. Okay. What is the salary they are getting? You can see getting more salary. In an average, it is M equal to 49,000. And what is standard error? Standard errors you can also notice. Okay, standard error equal to 1973. Okay, 0.035. Than the female faculty members. What is their mean? 39,000. Mean equal to 39,400. Okay. So what is the standard error? You can also report here 1686 point something. Okay, that you can that difference is significant. Why significant it is? T value equal to 4.088. Okay, and P is less than 0.05. Is it understood? This is what you need to write in your research report. That means there is a significant difference in salary practices given to the male faculty members and female faculty members in private institutions. Therefore, null hypothesis is rejected. What the null hypothesis states? Null hypothesis states that there is no significant difference. Okay, but here it has been found there is a significant difference. Therefore, H1 is accepted, H0 or null hypothesis is rejected. Is it understood?
Yes, sir.
Great. There are three more tests we need to do. Okay. So what kind of data set? What should be your, like, can you give me some insights into paired sample t-test? Anybody who has understood? Paired sample t-test. See, paired sample t-test, we are talking about paired. That means here the same observer is a same respondent is observed twice, before and after a treatment. Okay, just as I cited one examples like Kalinganagar area, take for example. Okay, so there are many tribal people who are living. So when the project Tata project came, there are many people who are displaced by the Tata projects. So their socio-economic conditions before and after the projects, that you can test it. Okay, you can test it. Similarly, when in case of clinical or medical clinical psychology, okay, people are having stress and they are going to different psychiatrists. Psychiatrist is what psychiatrist normally does. They normally politely talk to the people, and this kind of people who are stressful, they want a person who should listen to them, who should understand them. Whereas in family, on in family and pressures group, what they nobody understand. They simply impose certain kind of but blames on them that you don't understand. As a result of the which they also get stressed. So when they go to a psychologist, psychologist is simple. Sometimes what happens, for namesake, they also give certain kind of medicines, but medicine may not be useful. But what happens, the way psychiatrist talks, okay, that has also a certain impact. So impact of counseling on stress reductions, you can have also like this some patients they like the stress level can be also measured using certain kind of that instruments. Now there are many kinds of instrument, even if using AI is also helping with how their stress, whether by counseling stress is coming down or not, that you can have also. Basically this paired sample t-test is used when you have what you call that a treatment before and after, okay, and interventions. Okay, so here ABC University has arranged a specially faculty development program for one segment of the teachers, and the university wants to measure the change in the attitude of the teachers after FDP. Okay, for this purpose it is used a well designed questionnaire which consists of 10 questions on a 1.5 scales. Okay, one for strongly agree and five for strongly disagree. Thus, university selected a random sample of 20 teachers. Okay. So this is so normally if you see here the data, what we have done instead of 1.5, what we have done 10 to 50 we have done. Okay. So this is the before treatment. This is the before treatment, and this is the after treatment. These are all numeric value. You can see. So we don't study here whether it's a the patient or the faculty is a male or female. So therefore we don't have that strange variable like male faculty, female faculty. We are not checking whether the treatment has worked better in case of male faculty than female faculty, and vice versa. We are not going to check. Overall, we are not going to take here the that strange variable, okay, text-based variable, if you see gender kind of things, okay, or caste kind of things. Okay. So simple before and after we have collected. We want to see whether uh, there is a difference, a significant difference or not. Please bear in mind, when you don't have a strange variable or nominal measures, so you cannot run a Levin test. Homogeneity of variance, you cannot test it. So what you need to do here, you need to only test the normality of the data. Okay. So now we can go for normality check. So you can go for descriptive statistics, explore, then before and after, there is no factor list. Okay. So you can see descriptive statistics plot. You can go for this normality plot. You see 11 test is not there because there is no factor variable. Okay. Then histogram, you can go for this. The same thing, we are repeating the process. Then options, do you know no missing value here? Continue. Okay. Then both will see. So you see, this is before faculty development program. This is N. 20 people are there. After also 20 people have been measured. Again, descriptive statistics you can see. So before training program, their at measurement it was 24 point something 75. After faculty development program, change of attitude has been measured as 33.25. So there is an impact. It seems there is an impact. There is change. Okay. This change, this difference is significant that we can check it by using paired sample t-test. Okay. So one more, you see skewness, you see slightly it is different. Slightly it will have, because it has to be less than -1. Okay. So in between this score has to, sorry, this score has to be between -1 and +1. It is a slightly difference. Okay. Okay. Test of normality will see. But if you see the test of normality, it is, yes, it has to be greater than 0.05. And here also it is greater than 0.05. That means the data is normal. There is no level test we have done because we don't have strange variable here, or nominal measures we don't have. Okay. Similarly, if you see this histogram, you can see, you can check the, you can superimpose elements. Okay, this looks normal. Okay, there is this looks normal. QQ plot, you can see this is also okay. This is not required. This will appear as null. Okay. Histogram of after this histogram, you can check elements, show distribution curve. Okay. So this is also normal. You can run it. Okay. That means data is suitable now. Okay. So now we'll run a paired sample t-test of this. Analyze, compare means, you see. Step, please note down the steps. Analyze, because we are comparing means. It is paired sample. Sample 1 before and sample 1 after. We don't need to do anything. There is no missing data. Then we can go for OK. And see, this is the mean before faculty development program 24.75, and after it is 33.25. Okay, this is the sample size, this is the standard deviation, this is standard error. Correlation, you can see whether there is a correlation between before and after faculty development program. So the change of attitudes before and after. Okay. So this has been taken into considerations. So has been found that there is a very weak correlations. Weak correlation means up to 0.3 up to Okay, there is a weak positive correlation is there, but positive weak correlations. Okay, here if you see correlation is 0.23, means it is positive but weak correlation between before and after. Okay. This is not significant. Okay, you can see this paired sample t-test, mean value. This has been found minus 8.5. How it has been? This is the difference actually. 33.25 minus 24.75. So this has come here. Okay, lower bound and upper bound. Okay. So then t value, this is the t value actually, minus 7.96. Then degree of freedom is 90. So this has been found to be significant. Okay, this has been found to be significant. It means, what does it mean? There is a significant difference. That means when we conduct faculty development program for the faculty members to bring about positive change in attitudes among the faculty towards academia, this is becoming useful. Okay, so what you can report here, you can report here the t value, degree of freedom, and the significant value is 0.0. That's all. Got it?
Yes, sir.
We'll take 5 minutes break. Okay, then we will continue.
Okay, sir.
Okay, welcome back. Am I audible?
Yes,
Yes.
sir.
What are the prerequisites to run ANOVA? Could you please tell me, anybody? Yes. Okay. Could you please tell me? Hopefully you have forgotten. I have to go back once again here. You can see here the difference. This is two sample test we have done independent t-test. The scores are independent, just as boys and girls we talked about. But here the scores are not that. These are not independent. These are inclusive. These are exclusive. Inclusive means same observer measured twice here. Okay. But here you see this is the when your sample size is two, like two group sample, like male and female, boys and girls. Okay, and likewise. Okay, two. So you are using this independent t-test. But when your sample size is more than two, what does it mean? It is not boys and girls. Rather, you are making high promotion, you are making medium promotion, you are making low promotion. Okay, you are defining what is a low promotion, high promotion, and medium promotions. Okay, so in that case, your sample size is has become three now. Okay, three group samples. Therefore, you have to run this. So before running this ANOVA, what you need to do, you have to check the normality of the data and homogeneity of the data also as well. You have to also see. Okay. So I have opened. You can check one store promotions. One data set I have said in the morning store promotions. Okay, promotions. You can see it is we have given as 1 to 3, 1 for high promotion, 2 for medium promotion, 3 for low promotion we have given. Okay, these are coded. Okay. And after coding we have made this variable as numeric, but actually it is a string variable. Okay, there here you see here measure is nominal, but here scale, because for the cells we are measuring here. Okay, we have not coded it, is not because it is metric variable, we don't need to code here. Okay, this is a sales performance. So these are reflecting here. You can see 1, 2, 3. You can also decimal. Let us not write decimals. Okay. Let us not, sorry. Let us not write decimals. And see 1, 2. Likewise, we have a sample size of 30. And see. So for high promotion, low promotion, and medium promotion, 10, 10, 10. These cells we have collected. Okay, so we'll check now the normality and mm, homogeneity, descriptive statistics, explore. In store promotion, this has to be in factor list. This is the dependent list. You can go check these statistics. This is fine. Plot, if you want to check histogram and normality, you can have it on transformed. Okay, Levin test homogeneity. Okay, then you can have these options, not required anything because there is no missing data. Okay, then you can go for both statistics and plot. Okay, you can see 10, 10, 10. There is no missing value, everything is fine. Then mean, when we are doing mean promotion, see, when we are making mean promotion, we are getting for average sales of 93,700 per day. Okay, but whereas it is medium promotion, the mean is reducing to 67,900 per day. Let us see here. Okay, so it is also 40,600. That's why what it means. It is looking that when we are spending more money on advertisement or store promotion, we are getting good results. So therefore, the difference is coming as here 40,600, here 67,900, here 97,700. Okay. 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 So we are ready. Now let us see the kurtosis. Skewness and kurtosis, you see, it is slightly higher. It has to be in between +1 and -1. It is slightly that lower, it seems. Okay. Second day, like sorry, this is medium promotion. It is fine. You can see. Then you can see here. This is also fine. Okay. So here there is some problems. It seems. Okay, the data doesn't seem to be normal. Slightly, it is lesser than the normal. Okay. We'll check the normality. Test of normality. Test of normality. What does it say? This test of normality, you see, when we are doing high promotion, we are getting, this is the case test, we are getting this non-significant, we are getting this 0.2 means non-significant, it is desirable for parametric test. When medium promotion we are doing, okay, so now it is becoming also 0.2. When we make low promotions, once again it is 0.2. Okay, best and means, if you see these are the means test. Best and means, what we are doing here 0.2 we are getting. That means once again we are getting also, this is also non-significant. What is desirable? This is also desirable to run a test like this. Okay. Okay. Now we'll run this ANOVA. Okay. For ANOVA, what we need to do, analyze, compare means, once again, compare means one way ANOVA. Okay. We have in store promotions, we'll take it here. This is per day sales dependent list. You can write, everybody follow the steps. I believe that there may be some research scholars who are attending this FDP. This will help. Okay. So then you can have this contrast. Okay. Okay. In contrast, we don't need to do anything. Then post hoc, born for any. Why we need to check born for any? Because sometimes what happens, the store may need to combine the different kinds of promotions. That means sometimes it will make low promotion and high promotion, low and medium, or high and medium kind of promotions that it will make. Okay? Therefore, in comparisons, we can see whether we are making, suppose we are making two kinds of promotion, instead of going for low, medium, we will do. Whether it will work or not, whether the promotional campaign will be effective or not. Okay. Then you can have it here, continue. Then options, you can go for this. Just a minute. Sir, namaskar. ଆଜ୍ଞା ହଁ ସାର୍ ଦେଇଦେବି ସାର୍ ଯଥା ସାର୍ 22-23 ବର୍ତ୍ତମାନ ସୁଦ୍ଧା ଅଛି। ହଁ ଆସିଥିଲା ଏଇ 30ଟା ଖଣ୍ଡେ ଆସିଥିଲା। ହଁ ସାର୍ ଟିକେ କଥା ହଉଛି ଟିକେ ପଛରେ ଗୋଟେ ଏଫଡିବି ରେ କ୍ଲାସ ନଉଛି ଆକ୍ଚୁଆଲି କଥା ହେବି। Welcome back. There is one important, therefore I have to attend. Okay. Descriptive you can check. Okay. Then you can check also homogeneity of variance. Okay. Then you can also check this mean plot. Mean plot is required because we have to check whether the when you increase the budget for, or when you spend more for this promotion, whether our that sales is increasing or not. Okay. Then continue. Then nothing to do here. Okay. Then here you can see. Yeah. So descriptive it is coming 10, 10, 10, then 93,700, then 67,900, low promotion 40,600. Okay. Test of homogeneity you can see this is also becoming significant. You can see it is non-significant. It is what is desirable. Okay. Another table you can see here. Another table you can see uh, when this is born for any, that's something that we have selected. So when we did this in combination, we can see high promotion and medium promotion we are getting, it is significant, that is becoming useful. Okay. When we also make high promotion, low promotion, it is also becoming significant. Okay. Medium promotion and high promotion, if you see, it is also becoming significant. Medium promotion, low promotions, it is also becoming significant. So however, when we make like promotions, we spend in promotion of the product, so this is becoming significant. Then mean plot we can also see. Mean plot you see. Low promotions, when you spend less in promotions, what happens? The trend line is also, if you see, it is also increasing. Okay. That means the advertisement has a significant impact on sales, positive impact. This we want to conclude. Okay. Starts. Another table you can see. this you need to. So here you are getting between groups and within the group. Okay. Between groups, if you see, there are three groups. Okay, low promotion, medium promotion, and high promotions. So degree of freedom is sample that this is 3 minus 1 equal 2. Okay, this is all between. Within group we have got how many? 30. Okay. 30 sample size. 30 minus 3 groups are there, it is 27. Okay. So normally what happens between groups, sum of square value always is great here. Sum of square always it will be great than the within group. So mean square if you see, okay, so mean square is sum of square by degree of freedom. Mean square, sum of square divided by degree of freedom, we are getting this value. Okay, similarly within groups, this divided with this, we are getting this value. Okay. So now we are getting also significant, p value is significant. So what we need to report? We need to report in our research report that there is a significant, there is what significant impact of sales promotions on sales. When we, that means when we increase the spending on sales, we are also getting increased sales value. Okay, you can report this value f equal to 662.402 and p value is less than 0.05. Okay, this you can do it. Okay, is there any questions that I can take? One more test is there, that will take time. Hopefully before commencement of the third sessions of the day I will discuss that one. Okay, so is there any concerns that I can address?
Is there any question from the participants?
There is a question, can we test with one dependent and many independent? Who is Ruma Bhatt?
Hello.
Ruma Bhatt is there.
Good morning, sir.
Can you clarify your questions here? This seems that you want a kind of test like a regression.
Uh, Actually, not regression. Actually, I want to compare the means with the other factors. Like in my case, suppose one is independent, three independent
Hmm.
and one dependent factor, and I want to see that how it is varying in different groups. I have also divided, taking different areas for
Hmm.
my study, and
Hmm.
how it is varying. These three factors are varying with respect to the dependent variable in different areas selected.
Hmm.
So can it be checked in ANOVA?
It will be.
So which type of ANOVA? Should it be like one-way ANOVA or?
See,
Yeah.
when you discuss about ANOVA, okay, you
Yes,
make a
sir.
matrix. Whether
Yes.
you want in two way, what you do, both the way means column and that row, both are you are checking.
Yes, sir.
Okay, both column and you are comparing both column wise and row wise difference also we are checking. Okay, in one way you are only checking the row. It depends actually where you are putting what.
Okay.
Okay, where you are putting what. Two way means row and column, both you are checking. One way means it is just row you are checking.
Okay.
Yeah. That
So
matrix you have to
should
prepare.
I use then two-way for this comparing different many independent with one independent in different areas? Can I do that, sir?
No, you cannot have just one column.
Yes.
You cannot have one column. It is three, na? That more than
Yes,
two
sir.
samples. When you are taking more than two samples, na?
Hmm.
Okay. So your column distribution and row distribution has to be also accordingly, like that. If
Okay.
you have one column, say you are putting your dependent or independent variable there, with whom? Because you don't have other columns to compare.
Hmm.
Are you getting?
Yes, sir.
Column wise you are comparison you are making, so you have only one, you cannot,
Okay. Okay.
like that. Okay.
Yes, sir.
Thank you.
Thank you, sir.
Uh, is there any other questions that I can address? Okay, fine. In the afternoon session at 3 o'clock, please do join positively at 3 o'clock. What we'll do, we'll start with these repeated measures. We'll complete this one. Then we'll go for other kind of tests like Manhattan test, Wilcoxon test, take for example. Then we have also Friedman ANOVA. We have Kruskal Wallis. Okay, these types of tests we'll check very quickly. We'll wrap up the sessions. That third sessions today. Okay, because we have one pending test is there. Okay, so we'll stop here. Okay, thank you very much.
Okay.
Thank you, sir. Good morning,
Thank you,
everyone.
sir.
As we have come to the end of session 10, I, Dr. Diptimay Panda, would like to thank our distinguished speaker, Dr. Chandrakanta Sahoo sir, for being online with us and presenting an insightful and engaging session on hypothesis testing using parametric test. We are eagerly waiting for your upcoming session in the afternoon. Thank you, sir. Now we'll have a short break and our next session will be start from 11:30 a.m. All are requested to join on time. Thank you, sir. Thank you, everyone.
Welcome, ma'am.